Good evening. Today we're gonna learn about object-oriented programming part 3. And in this slide, specifically, we want to learn about abstract classes. What is an abstract class? An abstract class can be considered as a blueprint for other classes. It allows you to create a set of methods that must be created within any child class built from the abstract class. A class which contains one or more abstract class uh, a class which contains one or more abstract method is called an abstract class, and that's the main difference between an abstract class and a non-abstract class. So, an abstract class can contain one or more abstract method, but it doesn't need to contain abstract method. But for a non-abstract class, it cannot contain an abstract method. What is an abstract method then? An abstract method is a method that has a declaration but does not have an implementation. So let's see the example here. On the left hand side, there are examples of non-abstract class. Non-abstract class mean class that we actually can create objects, right? We can create rectangle, triangle, and square, right? But we cannot create shape. Suppose that I ask you to draw a shape, you will not be able to draw a shape because a shape can be a rectangle or a triangle or a square. I need to be specific about what kind of shape that I want you to draw, right? And other set of example of non-abstract class are dog, cat, bird. So if I say like let's go to see a dog, then everyone understand that I'm gonna go to see a dog, right? But if I say that let's go to see an animal, then some people may think that an animal here is a dog, but some people may think that an animal here is a cat. So here, shape and animal are abstract. It uh, can be anything, right? It does not have a clear picture about what it is, right? Um, Another set is orange, banana, strawberry. If I say that I want to eat an orange, then you can bring an orange to me, right? But if I say that I want to eat a fruit, then you would not know, oh, what kind of fruit that you should bring to me, because fruit is better to describe by using abstract class. It's not concrete. It's not specific thing that everyone will understand the same. So why use abstract class? Because we want to provide a common interface for related class, enforce certain methods to be implemented by subclass, allow for code reuse, and maintain a clear class hierarchy, enable polymorphism, and increase flexibility in design. And these are the benefits of abstract class. It will ensure consistency across related class, prevent instantiation of base class that should not be used directly, right? Uh, Instantiation here mean create the object, right? I should not create an object of shape, right? Because shape can be anything, right? Or I cannot create an object of animal because animal can be any type of animal. And but why do we want to have an abstract class? Like for shape, every kind of shape will have color, right? So color should be like the attribute that is inherited to other subclasses. Or like every shape should be able to draw, right? So there should be draw method, and it should be an abstract method because for different kinds of shapes the draw method will act differently. So we want subclass of shape to implement draw for specific uh, uh, kind of drawing in its own type, in its own subclass. And by having an abstract class, it also facilitate future extensions. Like we can easily add subclass, or we can uh, specify like certain method that we want to every subclass to be inherited. And so these are the examples, right? Here we would implement subclass, right? Rectangle, triangle, square as subclass of superclass shape, and superclass shape will have color because every kind of shape will need to have color. And dog, cat, bird are subclass of animals, and animals should have the attribute num legs. Even though some animal may not have legs, then num leg is zero, right? And if we have an abstract class fruit, then its subclass may be orange, banana, strawberry, and every fruit will have taste, right? So we can have taste as an attribute that other classes can be inherited from. Okay, by default, Python does not provide abstract class. Python comes with a module which provide the base for defining abstract base class or ABC. So ABC stands for abstract base class. And that module name is ABC, which is in package ABC plus. So we have class ABC, okay? We have module ABC. And ABC is in package ABC plus. ABC works by decorating methods of the base class as abstract and then registering concrete classes as implementations of the abstract base. And a method become abstract when decorated with the keyword at abstract method. Okay, let's see the process how to install uh, the package ABC plus. Here we're gonna use pip install ABC plus. And if you install ABC plus successfully, you should see the message successfully install ABC plus 0.1.0. But for on Windows, you need to run command as an administrator and then upgrade pip version and install package ABC plus. So this is how you would do we are using Visual Studio Code. So on Windows, you can type CMD on search box to search for command prompt. And when command prompt search result appears, then you right click and choose to run as administrator. And then after that, on the command prompt window, you would type the command Python option M pip install option upgrade pip. And then after that, you type pip install ABC plus to install package ABC plus. Okay, and then after you have package ABC plus and ABC installed, then you can use from package ABC import ABC and abstract method. Without this, you would not be able to implement and create. You would not be able to use abstract class. So at line number 4 here, we want to specify that class shape here is an abstract class by having class shape is a subclass of ABC. And please remember ABC stands for abstract base class, right? So shape is also an abstract class. So is a subclass of abstract base class. And here by importing ABC plus package, now we can use decorator add abstract method to specify that area and parameter here are abstract methods. And then in class rectangle is a subclass of class shape. And in the method, we accept the input parameter width and height. And then here in the method area, which we actually like inherit from class shape, right? Because now rectangle is a subclass of class shape. But class shape, the method area here, we implement at abstract method by having at abstract method and the body has the keyword pass task mean do nothing. But here in the area of rectangle, we say that, oh, if you want to get the area, you just return cell dot width multiplied with cell dot height, and then for parameter is to return to multiply with cell width plus cell height. And then in the main method, we can try to create the object of rectangle. We can create the object of rectangle, right? Because rectangle is not an abstract class. And then after that, we can call the area of the rectangle, and then we will get the value of area and parameter. Okay, now what if we create the object of an abstract class? What will happen? Here we import ABC and we say that class abstract class here is a subclass, right? Because it's inherited from package abc.abc, and it has the method as abstract method. And then at line number 10 here, we say abstract object equal to abstract class. We try to instantiate class, which is an abstract class. And now we can see that there's type error. The Python interpreter will tell us that we cannot instantiate abstract class, which the name is abstract class, with abstract method, with the name as method. So here we cannot create the object of an abstract class. So we can make an abstract class by having it inherit from abc.abc, right? And we mark abstract method with the decorator at abc.abstract method. And subclass need to implement abstract method. If subclass doesn't implement abstract method, then there will be error. Let's see the example here. Here we have abstract class, which is a subclass of ABC, and subclass here is a subclass of abstract class. And in abstract class, we have method as abstract method, and this means that all subclass of abstract class needs to implement or specify the body of the method, uh, which is called method here. But here you can see that subclass doesn't implement the method here. So that's why there's a type error at line number 15. We cannot create the object of subclass that doesn't implement abstract method. So subclass that implement an abstract class method will uh, inherit, which is inherited from an abstract class. Now, you can see that subclass now has the definition of method, and method here is inherited from superclass abstract class, and abstract class here specify that method is abstract method. So for all subclass needs to define the method that is abstract method. And now we define that method, so that's why now we can run the program successfully. So let's see another example of abstract class. Here we need to import ABC abstract method from package ABC, and then class polygon here is an abstract class because it's inherited from class ABC. And then here we have two abstract methods, init and string. So that means all the subclass of polygon need to implement method init and string. So here class triangle, which is subclass of polygon, have the defined method init, which is called the init method of the superclass with the name as triangle. So here the init method here says cell.name equal to name. And then for string, it just return that the triangle has 3 sides. And for pentagon, the string will say that pentagon has 5 sides. Hexagon has 6 sides, and the name also changed to hexagon. And conic rectangle quadrilateral has four sides. And now we can we can see that the comment is comment on line number 56 because we cannot create the object of abstract class. If we have code at line number 56, then there will be an error. But we can create the object of subclass like triangle, quadrilateral, pentagon, and hexagon. And all of these objects are actually in class shape, right? Because the subclass of the class of all these objects are subclass of class shape. So here that's why we can say for shape in polygon spin shape. And suppose that if there are more than or equal to two methods, then the subclass need to implement all abstract methods. Otherwise, there will be a type error here. So you can see that there will be error if we don't implement all abstract methods in the abstract class. And here we also see the example of having subclass directly from the base. We can avoid the need to register the class efficiently. So here we have class parent, right? And class parent here has the method geeks, right? And uh, the method uh, geeks here also like print child class here. So here we can actually call the function is subclass to check whether child is subclass of parent and whether child is instance uh, of parent. So here when we instance it mean object, right? So that's why here we have child parentheses, open parentheses, and close parentheses. But here we want to check whether the class is a subclass, so we need to have just specify the class name. But here we need to specify the object, right? Because instance mean object. And we cannot create, so please remember that we cannot create an object of abstract class, and we cannot uh, we actually uh, need to implement all the abstract method in the subclass of abstract method. Okay, here this the demo problem one, where you need to define an abstract class fruit that define two abstract method ini and string, and two non-abstract methods set test and get test. And if you define class orange successfully by having orange as a class of fruit, then you can test the program with by creating the object of orange and then call the function set test and then print the orange object again. And now we can see that uh, it will say that orange has taste as sweet and sour, because here we set taste as sweet and sour. Okay, so now let's see the concrete methods in abstract math class. Concrete class contain only concrete methods. What I mean by concrete class are non-abstract class, the normal class that we have learned. And what I mean by concrete methods are the methods that we don't have decorated uh, as abstract method. On the other hand, abstract class can contain both concrete method and abstract methods. And concrete class provide an implementation of abstract methods. Like when we mean provide an implementation, it means like the abstract class or the abstract method that the subclass inherit from abstract method. In the abstract method in abstract class, we need to define that method in the subclass. Uh, the abstract base class can also provide implementation by invoking the methods via super. So let's see the example of concrete class and abstract class here. Here we have super one as abstract class because it's inherit from ABC. And here this abstract class doesn't need to have a abstract method because here method one is concrete method. It doesn't have decoration abstract method. And here in subclass, which is subclass of super one, we have method one, and here we reuse by calling super dot method and then print subclass. And here we can create the subclass object and also call the method one of subclass. But let's see this example. In this example, parent is an abstract class, and it also has uh, geeks as abstract method because we have a decoration abstract method here. And class child, um, it subclass of parent, and in this method geeks, it return child class. And here, when we try to create the object of parent, we cannot do that because we cannot create the object of abstract class. So abstract class are incomplete because they may have method that have no body, which means abstract method. So if Python allow creating an object for an abstract class, then using that object, if anyone call the abstract class, that abstract method, but there is no actual implementation to invoke. So we use an abstract class as a template, and according to the need, we extend it and build on it before we can use it. So due to that fact, an abstract class is not a concrete class. It cannot be instantiated or it cannot be created as an object. So when we create an object for the abstract class, we'll get an error. Okay, the next topic that we're gonna learn is docstring. So docstring here means documentation string. They are string literals that appear right after the definition of a function, method, class, or a module. So here, this is the documentation string for the method because it appears right after the method definition. So in order to define documentation string in Python, you need to enclose in triple quotes. It can be triple double quotes or triple single quotes, but normally we would see triple double quotes. And the document string will be the first string after the division. It can be string or multi-line. And the documentation string can be accessible via a doc attribute. So why do we use document strings? Because it can be used to improve code readability. Docstring provide immediate context and explanation for functions, class, and modules. It also standardized format. Docstrings have a standardized format in the Python community, which make them easy to read and write consistently across different projects and teams. And tool integration. Many development tools and IDEs use docstring to provide context-sensitive help. For example, when you hover over a function name in many IDEs, it will display the function docstring. In addition, docstring also make automatic documentation generation. possible, right? Tools like Sphinx can automatically generate comprehensive documentation for your project by extracting and formatting the docstring in your code. And if we implement API, which stands for Application Programming Interface, it's like the method, the functions that can be used across computers on the network by calling the API. Then docstring serve as a built-in form of API documentation, make it easier for user of your code to understand how to use various functions and classes. And docstring also help in code maintenance. Well-written docstring made it easier to maintain code over time. They provide context that can be crucial when revisiting code after a long period or when onboarding new team members. So, for the best practice of defining docstring, be concise but informative. Concise means uh, not uh, not write anything that is not useful or not uh, relevant to what we are doing. And also include parameter description, return values, and exception. Use consistent formatting. Keep the string up to date with code changes. So this is an example of docstring in the class circle. So here we have docstring, and you can see T double quote here, right? So the string inside three double quote here and three double quote here are doc strings, and this doc string explain about what class circle is, and then inside the definition function in it we also have the doc string to explain about the init method, and in the area we also have doc string to explain about area. And then when we use it, we use doc attribute, right? And here we print circle dot doc, print uh, circle dot init dot doc, print circle dot area dot doc. And here we can see that we have now none as the first output, because here when we say print doc is actually print the doc string of the module. And here in this module, we don't have docstring. So that's why it returns none. On the other hand, we have docstring for class. So here we can see the string that we describe here. And later we also have docstring for ini and docstring for area. So the reason that we seeing none as the first line, because doc at the module level, which is what print doc is, printing is not divided in the code, right? So print doc, this will print the doc string of the current module. Since you haven't defined a module level doc string, it print none. But for circle, it will print the doc string of circle class. And for print circle dot init dot doc, this print the doc string of any method. And for circle.area.doc, this print the doc string of the area method. And these are example of doc string that now we have the document string for the module, which is defined as the first line of the program. And here for each method, we also have the doc string for each method. And this we print the doc string for the module and for each method. And this what should be the output of the doc strings print out via the doc attribute. So the key concept in OP is that abstract class are blueprint for other classes, and concrete class can implement all method. Abstract class may have unimplemented method. So in conclusion, abstract class define common interface for set of subclass, and Python ABC module enable creation of abstract-based class. So I hope that in this slide and video, it will help you to understand more about abstract. Thank you.